MCA Prep Packet, Day 5. We're starting out with benchmark 8222. You can find this in your packet on page number 23. Benchmark 8222. Identify graphical properties of linear functions, including slopes and intercepts. Know that the slope equals the rate of change and that the y-intercept is 0 when the function represents a proportional relationship. Number 1, part A. What is the slope of the line shown? To find the slope, you may recall that the slope is equal to rise over run, or the change in y divided by the change in x, or even, you may remember, the slope formula, y2 minus y1 over x2 minus x1. That formula will be on your formula sheet for your MCA. Now, when I'm looking at a graph, I like to use rise over run to figure out my slope, so that's what I'm going to go with here. I'm going to start at the point on the left, and I'm going to count how many I need to rise and then run to get to the point on the right. So, starting at the left, I would go up 1, 2, 3, 4. So I'm rising 4, and then my run 1, 2, 3 to the right. So my slope is 4 thirds. Rise 4, run 3. So you write that as a fraction, 4 thirds. Remember that a positive slope, a slope that is positive is going up from left to right. A slope that is negative is going down from left to right. And a slope that is 0 is horizontal. A slope that is undefined is vertical. So those are the 4 different types of slopes. Now part B says, what are the x and y intercepts? The x-intercept would be the point where the graph crosses the x-axis. So where the line that's graphed intersects with the x-axis. So that point would be right here. So my x-intercept equals -3, or as an ordered pair, it would be -3, 0. And then my y-intercept is where the line crosses through the y-axis or intersects with the y-axis, so right here in green. So my y-intercept equals 4, or as an ordered pair, that would be 0, 4. Our next benchmark is 8223, so that would be on the following page, page number 25. Identify how coefficient changes in the equation f of x equals mx plus b affect the graphs of linear functions, and know how to use graphing technology to examine these effects. Number 1, part A, the graph of the equation f of x equals 2x plus 4 is a line. What could be the equation of a line steeper than this line? Okay, this is a very good question. And in order to answer it, I am going to graph the line. So, trying to find a good spot for this. Shrink it down a little bit more. Okay, so f of x equals 2x plus 4 has an intercept of 4 and a slope of 2. So I'm starting at 4 on the y-axis, and I'm going to go up 2 over 1 to draw my line. So here is f of x equals 2x plus 4. Now, the question for part A was, what could be the equation of a line steeper than this line? Steeper. Like think about a hill. If it's a steeper hill, that means that my slope is not going to rise 2 run 1, it's going to have to rise more than 2. So I'm going to say it's going to be, if I start at the same intercept, I'm going to go up 1, 2, 3, 4, 5 and over 1, like this. Or if I go down 1, 2, 3, 4, 5, and back 1. So this line is steeper than my first one. So steeper, what I did was I increased my slope to 5. Increasing it from 2 to 5 means that I was going up 5 over 1, not just up 2 over 1. So that made my line steeper, a higher number in front of x. Okay, now part B says, what could be the equation of a line that has a y-intercept above the line? So a y-intercept above the line, well, this intercept was 4. So a y-intercept above that just means something higher than 4. So I could say 2x plus 7, because 7 is higher than 4 on my y-axis. So this benchmark is talking about how changing the coefficients, changing the slope, you can make your line steeper. You may see terminology like on Study Island, they would say that this was rising more quickly because it was a positive slope. So they use terms like rising more quickly, or for negative slopes they might say falling more quickly, something like that. So rising is when it's increasing, when it's a positive slope. Falling is when it's a negative slope. Falling more quickly would mean that it's steeper, just like rising more quickly is. And then changing the y-intercept, that's going to change where it goes through the y-axis. So that's different than changing the slope or the steepness of your line. Remember, you can always draw graphs to help you answer these questions and check and see if you've got the correct answer. Graphing is always good. Okay, our next benchmark, 8224. Represent arithmetic sequences using equations, tables, graphs, and verbal descriptions, and use them to solve problems. So, this is on page number 27 in your packet. Number 1, Emily and Aaron bought supplies and set up a lemonade stand. They charged 50 cents per cup of lemonade. The equation f of x equals 0.50x minus 16 represents the amount of money earned by selling x cups of lemonade. So, part A says, how much money did Emily and Aaron spend on supplies before they sold any lemonade? Well, if you look at this equation, if you look at your equation here, now we know that they charged 50 cents per cup of lemonade. So you see that right here in the equation. And they aren't saying anything about that minus 16. So on part A, how much money did they spend on supplies? That's the $16 that's being subtracted right here. So they started out by spending $16 on supplies. It's a negative because they've spent that money and they're trying to earn it back. So 16 is what they started with, which was a negative because they spent $16. And then the 50 cents is what they're earning per cup of lemonade that they sell. Now for part B, it says that they sold 80 cups. So if I evaluate this function at 80, f of 80, we would take 50 cents times 80 and then subtract the $16 that they spent. 80 times 50 cents is $40. 40 minus 16 means that they have a profit of $24. So if they sell 80 cups of lemonade, they will make $24. Our next benchmark, 8225. This is on page number 29. Represent geometric sequences using equations, tables, graphs, and verbal descriptions, and use them to solve problems. In 2010, the population of Edina, Minnesota was about 45,600. Suppose that the population is predicted to double every 10 years. So it's going to double every 10 years. Part A, write an equation that can be used to predict the population after X 10-year periods. So it's going to double every 10 years. So my geometric sequence would look like this, where A represents our starting amount. So that would be the population, 45,600. And then, because it's doubling, that means that you would be multiplying by 2 to the power of x. And x represents 10-year periods, 10-year periods. So, for part B, the population in 2040, well, if this was 2010, so 2010, then I would have 2020, because we're going by 10-year periods, 2030, and 2040. So what number am I going to use for x? How many 10-year periods have we gone through? How many 10-year periods? So this would be 1 10-year period, 2, 3. So that means x equals 3. 3 10-year periods. So f of 3 equals 45,600 times 2 to the third power. So I'm going to use my calculator here. 45,600 times 2 to the power of 3 would give us a population of 364,800 people. I'm pretty sure they can't fit that many people in Edina. So I don't think that's going to end up being accurate for the year 2040. Just my thought. So again, be careful because they're talking about 10-year periods. So your instinct would probably be to say that there's 30 years between 2010 and 2040, but 30 years is only 3 10-year periods. So for my exponent, I need to use 3. Okay, the next benchmark, 8241. 8241. This should be on page number 35, I believe. 35 in your packet. Use linear equations to represent situations involving a constant rate of change, including proportional and non-proportional relationships. Part A. Number 1, a phone service provider charges 10 cents per minute used. So 10 cents per minute used. Write an equation that represents the total cost, C, for m minutes used. So my total cost, C, equals, if it's 10 cents per minute, that means I'm going to take that 10 cents and multiply it by how many minutes. Now this equation is going to be proportional because the intercept is 0. It would go through the origin. There is no additional extra fee added on. It's simply 10 cents per minute. So it's proportional and linear function. Okay, now the next one says another company charges $8 per month and 3 cents per minute used. So $8 per month and 3 cents per minute used. So their total cost would equal $8 plus 3 cents per minute. So when it says 3 cents per minute or 10 cents per minute, that's telling me that that's where that variable m for minutes is going to go. The $8 per month, that just happens once that month, and then it's in addition to that, you're adding on 3 cents every minute. So this situation, if you wanted in slope-intercept form, you could reverse the two numbers like that, and your equation's still equivalent. So this is not proportional, it's non-proportional because of that starting $8. Non-proportional, but it is still a linear function. It's still a line. And it would still pass the function vertical line test. So the difference between those two situations is that Part B had an $8 charge first. before the minutes that were used. Okay, that's it for your MCA prep for day 5. So you should be able to finish all of those pages in your packet.